This is Mr. Beck Does Your Homework, AP Physics, homework number 6.3, question number 13. A 1.8 kilogram object moving at a speed of 4 meters per second strikes a 1.3 kilogram object initially at rest. Immediately after the collision, the 1.8 kilogram object has a velocity of 1.4 meters per second, directed 44 degrees from its initial line of motion. What is the speed of the 1.3 kilogram object immediately after the collision? So I have an object moving, we'll just make it moving this way. And it's going to strike another object that is initially at rest. This one is 1.8 and it's moving at a velocity of 4 meters per second. This one is a 1.3 initially at rest, 1.3 kilograms initially at rest. After the collision, the 1.8, this one has a velocity of 1.44 degrees from its initial line of motion. So let's make that this way. So here's this object, and this angle here is 44 degrees. What is the speed of this object after the collision? So you're guessing that this one is going to go flying off in this direction. So one moving, one standing still beforehand. Afterwards, I've got this one moving that way and that one moving this way. Two things I know. Well, several things I know. I know that all my momentum was here beforehand, and it's all x momentum. So all the x momentum equals the total momentum. The total momentum is all in the x. So that'll tell me how much momentum I had beforehand in the x. Afterwards, I know the mass and the velocity of this one. If I know the mass and the velocity of this one, I can get my momentum here. That momentum is made up of a momentum in the x direction and a momentum in the y direction. This one is going to have some momentum in the x direction and some momentum in the y direction. And I know that this momentum in the y direction and this momentum in the y direction are going to be of the same magnitude. So this block that was here is going to now be here. These y have to be the same because they have to cancel out because there wasn't any y momentum beforehand, so there can't be any y momentum afterwards. This one has some x momentum. There was some total momentum beforehand that was all x, so this one's x momentum will be added to this one to equal this total. So if I take the total minus this, it tells me what's left over for this one. So I've got 1.8 times 4. My initial momentum is all x direction. So my momentum in the x direction is going to be my mass of 1.8 times my velocity of 4. And that's going to give me some total for my momentum in the x direction. My momentum in the y direction equals 0. That's beforehand. Afterwards, let's see, I've got 1.8 moving at a velocity of 1.4 meters per second. 1.4 meters per second. And this is 1.8 kilograms. So my total P here, this one, the top one, is going to have a momentum of 1.4 times 1.8. That's my momentum in this direction. Well, that gives me a Px equals my total momentum times the cosine of the angle, 44 degrees. This momentum is Py, and that's going to be my momentum times the sine of the angle. So this momentum, 1.4 times 1.8 times the sine of theta angle there. So now I know that this one is going to have the same momentum in the y direction, so that I can fill in pretty easily. This momentum in the x direction, this one, is going to be the difference between this momentum and this original momentum. So if I take this, my total Px minus this Px, it'll give me my Px for this one. And Py is going to, again, be identical to this one, just opposite direction. So now if I know Px and Py, I can figure out my total momentum here. And if I know my total momentum here, because I'm going to do a squared plus b squared equals c squared, so square root it, get my momentum at the hypotenuse, that momentum divided by the mass is going to give me my velocity because P equals mv. So if I take that and divide it by 1.3 kilograms, that's going to be P over 1.3. That'll give me the speed of that object after the collision. That'll give me this one. And it doesn't ask for the angle, but you could feel free to solve that angle if you wanted to.